Hi everybody. In this video, we are going to continue talking about graphing functions. This video is specifically relating to the second half of your PDF notes. So starting with question 7 and going on from there. All right, so in our first function here, we have f of x equals the cube root of negative 1/3 x plus 4. So our first job is going to be to identify the parent function, which is going to be just y equals the cube root of x. That's that basic function when we take away all of the addition and subtraction and multiplication, etc. Now, if you remember, cube root of x starts at the origin. If we put in 1 for x, the cube root of 1 is just 1. If we put in negative 1 for x, again, the cube root of negative 1 is also negative 1. When I'm graphing this function, I try to find the points that are easiest. So my next perfect cube would be 8. If I take the cube root of 8, I'm going to get 2. So if I put in 8 for x, I'll get out 2 for y. Same thing on the other side. If I put in negative 8 for x, the cube root of negative 8 is going to be negative 2. So that's going to help me draw this function, which, if I connect the dots fairly well, looks just like that. Now what we have to do is start to identify those transformations. So the first thing that I see here is this negative. So what that's going to do, because it is inside that cube root function, that's going to affect my x values. So that is going to reflect over the y-axis. The 1/3, again, because it's inside, it's affecting x, so it's a horizontal. And in this case, it's a horizontal stretch by 3. Remember, we take the reciprocal of that factor, so it's a horizontal stretch by 3. And then lastly, I have this plus 4, which will shift the graph up 4 units. All right, so as I graph it, I'm going to work from the inside out, adjusting each or making each change as I go. So I'm going to start with the negative. I'm going to start with that reflect over the y-axis. So the origin is going to remain. My positive 1 for x will become negative 1. And my negative 1 for x is going to become a positive 1. And then my 8s will flip as well. So negative 8, 2, and then 8, negative 2. So that flip over the y-axis will end up looking kind of like that. All right, the horizontal stretch by 3 gets a little trickier. So these are the ones where you might want to start thinking about putting in points. So if I were to put in the point f of 3 into, if I'm just talking about the cube root of negative 1/3 of x. So I'm going to not worry about the 4 quite yet, but I'm thinking about what's going to happen if I put in an f of 3. Well, if I put in an f of 3, the 3 times 1/3 becomes negative 1. So I have the cube root of negative 1, which we know is just negative 1. So an f of 3, my x value of 3, 1, 2, 3, will give me a y value of negative 1. That gives me this point down here. Now, I know the other way, if I do f of negative 3, that's going to end up with the same idea, that I'll take the cube root this time of, oops, not 3, sorry, take the cube root of 1, of that positive 1. So that'll give me an f of negative 3, y of positive 1. So you can start to see how this is going to build through. Now, the next thing, I'm going to be dividing by 3, right? So I know when I multiply by 1/3, I'm going to be dividing by 3 as well. So while it might not be a perfect cube, what I'm going to choose next to put in is f of 9. What that's going to then do is I'll have negative 1/3 times 9. So that's the cube root of negative 3. Now I'll tell you guys that is about negative 1 point, oops, negative 1.44, so 1.5. So if I go all the way out to x of 9, which is out here, my y value is about 1.5, just short of that, which means if I go out to negative 9, I'll have a positive 1/2, just shy of that. Okay, so this gives me those 5 key points. And what you're going to see is that horizontal stretch means that it doesn't get as tall. I'm stretching it out in the XY direction, in that horizontal direction, so it's not going to be as tall anymore. So that's what that horizontal stretch does. Now, lastly, I'm going to shift all of those points up 4 units. I'm just going to take each point and move it up in the Y direction 4 units. So I've got this blue one here that's at about 1.5, and I'm just going to move up 4. 1, 2, 3, 4. Here's my new Y. I'm going to do the same thing for each of these other points. So this is at 1, I'll go up 1, 2, 3, 4. This is at the origin, I'll go up 1, 2, 3, 4. 1, 2, 3, 4, and then 1, 2, 3, 4. So my final graph, when I sketch this out, is going to look like that, just about. So that yellow one will be my final product. That's what you definitely want to make sure you have on your graph. You don't have to show me all the iterations along the way if you don't want to. I just think it's helpful to kind of keep track. But that is that final function. All right, so our second function reads f of x equals 1 over 2x minus 1. So thinking back to our parent functions, we notice that the x is in the denominator. That's your giveaway that this function is indeed, the parent function is the reciprocal function, y equals 1 over x. Now, what's nice about this problem is there are no parentheses around that 2x. So what that allows us to do in this problem is to take a little bit of liberty with how we're addressing it. So what I'm actually going to do is rewrite this because I think it's going to make it a little bit easier. I'm going to rewrite this as 1/2 times 1 over x minus 1. Technically, because there's nothing else going on under in the denominator of that fraction, we can separate these. Once we do that, that makes that multiplication, that dilation, it makes it a vertical instead of a horizontal, which I think just makes things a little bit easier. We don't have to worry about flipping. We don't have to worry about anything like that. So I think that that's just helpful. So when we look at this function, we've got 2 changes. The 1/2 out in front, as I mentioned, is a vertical. So it's a vertical dilation, but because it's between 0 and 1, it's going to be a vertical compression. Vertical compression by that exact number, that 1/2. In addition, we've got this minus 1 on the outside, so that will just shift our function down 1. All right, so the reciprocal function, parent function, we know that we have an asymptote on the y-axis, right? So an imaginary line that's not going to cross. We also have an asymptote on the x-axis, so this imaginary line that the graph won't cross. If we put in an x value of 1, here in the denominator, if we put a value in of 1, we're going to get out 1. So here's that function here, or that point there. If we put in a value of 1/2, so 1 over 1/2, that's going to give us a y value of 2. So that creates this point up here. On the contrary, if we put in an x of 2, that creates a y value of 1/2. So what you're going to notice is that we're going to have this little boomerang shaped guy that's going to come down, and it's going to approach the asymptote. And then we have the same little boomerang guy on the other side. I did not draw that right, so sorry. So we're going to have the same guy on the other side, just reflected. So approaching the asymptote by the x-axis, and then continuing down and approaching the asymptote on the y-axis. So this one's a little hard to see with the vertical compression because everything is so small. But what we can think about is what happens if we put certain points in. So now what we're going to consider is the function f of x equals 1 over 2x. So now if we put an x value of 1 in, our y is going to be 1/2. An x of 1 and a y of 1/2. If I put an x of 1/2 in, so if I did x of 1/2, that's going to be 1 over 2 times 1/2, or just 1. So that creates this point here. If I were to do, just running out of room, if I were to do an f of 2, that's 1 over 2 times 2, or 4. So you can see that this is getting smaller and smaller. It's not growing as quickly. It makes sense. That's our vertical compression, that this is going to be closer to the asymptotes for longer. And then on the other side, we're going to have the same thing. Now again, this graph does not cross this asymptote. It just gets closer to it faster than the red one did. So like I said, this is a little hard to see on this graph, but we're going to make it work. The last thing we're going to do is this -1 on the end, which means we're going to shift everything down 1. Now what's kind of nice is not only does it shift the graph, but it also shifts the asymptotes. So it's going to make everything a little bit easier to see. So what I'm actually going to do is go ahead and draw that new asymptote in that's been shifted down 1. So now I can move each point down 1, a little hard to see. Let me make that a little closer over here. But it should be enough that we can create enough of a graph to show. So these points will all move down 1. And then we'll just draw in, and again, these are just sketches, you guys, so don't worry about being super duper accurate, but having some of those points in to see is really helpful. So to take note, when we have a function that has an asymptote, or asymptotes, when we have shifts, not only do we move the function, but we move those asymptotes as well. That's going to be your way of kind of keeping track of everything. In this case, because there was no horizontal shift, we don't have to worry about switching the y-axis asymptote anywhere. That doesn't have to move, just the x-axis one is going to go down 1. So that green graph, those 2 boomerangs, will be your final product for this function. Function number 9 takes us over to f of x equals 1/4 the absolute value of x plus 2 plus 5. So it's so funny, even if you read that equation out loud, you're going to hear what that parent function is, which is our absolute value function. So y equals the absolute value of x. So the changes that have happened have been this 1/4 out front, the plus 2 inside the absolute value, and the plus 5 on the outside. So the 1/4 is on the outside of that absolute value bracket, so that is going to be a vertical change, a vertical dilation, and it's going to be a vertical compression because it's between 0 and 1. So vertical compression by 1/4. The green is going to produce a shift left 2 units, and the yellow will produce a shift up 5. All right, so our absolute value function, we know starts at the origin. We've got a 1, 1, a 2, 2. We're going to create that V. So I'm just going to draw in a couple points, but I'm going to make sure we have a nice V here. Okay. The next thing we're going to do is the vertical compression by 4. So vertical compression, you want to think about squishing the balloon down from the top, right? If we do that, it's going to flatten out the balloon and make it out wider. Oftentimes when I'm thinking about what these values are going to be, I'm just going to multiply those y values by 1/4. So the 0, 0 will stay the same. However, where I have a y of 1, that's going to be 1/4 now. So that holds true for both of those. Where I have a 2, 2 times 1/4 is actually going to be 1/2. So that's where the next one's going to go. I think the easiest one to see is if we go all the way out to 4. 4 divided by, or 4 times 1/4, or 4 divided by 4 is going to give me 1, 3, 4. So I'm going to have that point right there. I think that is the easiest one to see. So now what you're going to see is that I've got this a little more spread out V than I had before. A little flatter. Now what I'm going to do is I'm going to take each of those points and just going to shift them to the left 2 units. So if I start all the way on the left-hand side, I'm going to shift over 2. I'll shift over 2, over 2. Here's my origin point shifted over 2. And then I just go back and I repeat the pattern. So here, this green V is going to have the same shape. I'm just shifted over to the left 2. Now what I have to do is shift it up 5. So each of those points, I'm just going to take that y value and move it up 5. 1, 2, 3, 4, 5. If I start all the way over on the left, I'm going to move to that center point. 1, 2, 3, 4, 5. Out to the outside edge. 1, 2, 3, 4, 5. And remember, we've got symmetry, so you'll really only have to do one side. And then from here, we can fill in those points. It's a little easier to see when you have some guidance from the other points. That was not particularly straight. Let me try that again for you guys. So the yellow graph is our final graph with that shift up 5 units. So this one's pretty nice. It kind of worked out a little bit easier. Hopefully what absolute value is a function you're a little more familiar with. But again, that yellow graph is the one that's going to be our final product. And those should be straight lines, but they're a little curved. Sorry, but no, they should be straight. Yeah, and that's our absolute value. All right, so number 10 is going to be the last one I'm going to do in this video. I'm going to leave 11 and 12 to you guys. Hopefully a function like this looks very familiar to you. We have f of x equals -3 times x minus 4 squared plus 6. So we do have that squared, that exponent of 2. So our parent function is going to be y equals x squared. And as a reminder, we've got a nice little parabola. So we've got the point 0, 0, 1, 1, 2, 4. And then we're just going to reflect those over the y-axis. So that is, generally speaking, what our parabola is going to look like. Now we need to talk about the transformations. So we've got this negative out in front. So again, when it's out in front, that's going to reflect over the x-axis. We've got this 3 here. It's out in front, so it's going to be a vertical dilation. In this case, it's going to be a vertical stretch by 3. Then we've got this -4 inside, so that's going to be a shift right 4. And then lastly, I guess I'll do it in black, we're going to shift up 6. All right, so that's kind of the order that I think we should go about doing it. Actually, no, we're going to work from the inside out. I think that'll be just a better pattern to go. So we're going to start by shifting to the right 4. 1, 2, 3, 4. So each of those points that we have is just going to get moved to the right 4 units. 1, 2, 3, 4. 2, 3, 4. All right, so now we have this U that has just been moved over to the right 4 units. Now what I'm going to do is reflect, I'll do the vertical, let's see, I'll reflect over the x-axis now. So we're going to have these points down here, and then 4 down that way, and 1, 2, 3, 4, 1, 2, 4 down that way. So now we've created this upside down U because of that negative sign out in front. Now we're going to do a vertical stretch by 3. So what that means is whatever y value I have, I'm going to multiply that by 3. So a y value of 0 is going to stay at 0, but a y of 1 is going to move up to 3. 1, 2, 3. So same thing on this one. Here I have a y of -4, so that's going to go down to -12. So this is 10, 11, 12. I'm actually going to draw them off the graph. So this is, again, a y of -4. Times 3 is going to give me -12. So I'm going to draw these two down here. So you can see that vertical stretch has made it longer. It's getting lower faster. So that's what that vertical stretch is going to do. The last thing we're going to do is take each of those y values and move it up 6 points or 6 units. So the one that's sitting on the x-axis, we're going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to take each of these 2 points here and move them up 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then the ones that are at -12 are going to move up to -6. Let's see. So we've got 1, 2, 3, 4, 5, 6, and 6. All right. So this parabola that I'm tracing in black is going to be my final product. I save that +6 to the very end because it's on the outside. Order of operations says we're going to do it that way. So again, it's that black upside down parabola that has been stretched and shifted and reflected that's going to give me my final graph. Hope this video has helped kind of outline how to go about doing some of this graphing. If you have any questions, please reach out and we'll definitely keep practicing these along the way. Hope you guys have a great day.